Now the title of this slide is spherical mirror. So before studying the spherical mirror, the reflection from the spherical mirror, we need to know some definitions. So first we define the object. So what is an object? Anything which gives out light rays, either it's on or reflected, is called an object. Okay, so objects then we classify into two parts: real object and virtual object. So what is a real object? All physical objects and light sources are real, which either scatter light rays or produces light rays. So any source which is given a light is we consider it as a real object. Now you can see in a diagram there is a point source, and that point source is emitting a light. So there are three rays which is coming out from there are number of rays, but in this diagram the only three rays are showing. So these three rays are coming out from the source. So this source is taking as a real object. Okay, no doubt this source is taken as the real object. The important thing is that the light rays are coming out from this object. Now we go to the second type is a virtual object. So what is a virtual object? In case of a virtual object, you can see a diagram. There is a difference between these two diagrams. The difference is that in a first diagram the rays are coming out from a point source. In a second diagram the rays are converging at a single point. In a second diagram the rays are converging on a single point. So by this thing we can differentiate the real object and a virtual object. Now we go to a definition of a virtual object. When converging incident rays incident on eye or an optical device, there is no single point from which light rays appear to be coming. In this case we say object is virtual. Further, when we draw a diagram of object or image, or a ray diagram of a image formation from a mirror, we will study further more about the real object, virtual object, and real images and virtual images. Now move forward to the next slide. Now continue our topic. Now we define a image. What is an image? So we define an image. The reproduction of object formed by a mirror or lens is called an image. Okay, so by the mirror or the lens we reproduce the object, and that reproduction is called image. Now image can be further divided into two parts. One is called real image and second one is called virtual image. So what is a real image? An image which is formed by actual convergence of the rays of light is called real image. It means when the rays of light coming after the reflection of mirror or after the refraction of lens, so wherever the two rays coming after reflection or refraction, they actually meet on some point, then the image formed is called real image. We will study it when we form an image by a mirror. Then you can easily understand by the ray diagram. Okay, so here you just remember this definition. Now what is a virtual image? Now what happen in a virtual image? When the rays are coming out, seems to coming out from the reflection of a mirror or by the refraction of the lens, and they seems to meet or cut each other at somewhere or at some point, then we can say that the image is a virtual image. So the rays are not after reflection, and after reflection the rays not actually cut each other, but they seems to cut each other. Okay, when they actually cut each other, then the image formed is called real image. When they seems or they appears to meet each other or appears to cut each other, then they are called virtual image. Okay, so this is about what is the object and what is a image. Now again comes to our topic, mirror. So now we define a mirror. So what is a mirror? It is a highly polished surface which is quite smooth and capable of reflecting a good fraction of light from its surface. So a mirror we use for a reflection. Further, mirror we can classify. So we can classify the mirror as a plane mirror and a spherical mirror. So this classification is on the basis of a surface. Plane mirror, we use a plane mirror in our house. So in our house the mirror which we use is a plane mirror. So because its surface is plane, so it is called plane mirror. The another kind of mirror on the basis of surface is called spherical mirror. So spherical mirror is further classified into two parts. One is called convex mirror and one is called the concave mirror. So what happens in a convex mirror? So surface is now not plane, it is a spherical surface. So now a spherical surface is inwards. If the spherical surface is inwards, so if it is inwards, then the mirror is called concave mirror. And the surface which is outward, the surface we are talking is a reflecting surface. If a reflecting surface is plane, then the mirror is called plane mirror. If the reflecting surface is spherical, then the mirror is called spherical mirror. Now that spherical surface is coming out, or it is outwards, then if the spherical surface is outwards, then the mirror is called convex mirror, and the spherical surface is inwards, then it is called concave mirror. Further we will see the diagrams also. So let's move to the next slide. Hello dear student, in this slide we will study the spherical mirror and the various terms which is related to the spherical mirror. So first we define a spherical mirror. So a definition is a mirror whose reflecting surface is a part of a hollow glass sphere known as a spherical mirror. So now there is a diagram in which the various terms related to a spherical mirror are shown. So we will study one by one the various terms related to the spherical mirror. So first term is a pole. So what is a pole? So as you see in a diagram, there are two diagrams. So in these two diagrams, in a first diagram the outer surface is silver coated, and when you see in a second diagram the inner surface is a silver coated. So in a first diagram the reflecting surface is a inner one is a reflecting surface, and in a second diagram the outer surface is a reflecting surface. Okay, so in first diagram the spherical mirror produced is a concave mirror, and in a second diagram the mirror formed is a convex mirror. So let's first study the various terms related to the spherical mirror. So first term is a pole. So pole is defined as the central point of mirror is called its pole. So as you see the center point, this is the hollow glass sphere, and we are forming a mirror from a part of that hollow sphere surface. So the middle point, the center point of that surface from which we are forming a mirror is called its pole, and we denote a pole by a P, as you can see in a diagram. Now second is the center of curvature. So what is the center of curvature? Center of curvature we denote by a C, and that center of curvature is a center of a hollow sphere from which a mirror is formed. जिस hollow sphere से हम मिरर बना रहे हैं उसका जो सेंटर होता है उसी को हम क्या बोलते हैं? सेंटर ऑफ कर्वेचर बोलते हैं, और इस सेंटर ऑफ कर्वेचर को हम किससे नोट करते हैं? सी से. Okay, now next move to radius of curvature. So radius of curvature we denote by a capital R. जो radius of curvature होती है उसको capital R से बताते हैं, and this radius of curvature is defined as the radius of a hollow glass sphere from which a mirror is formed. जिस hollow glass sphere है जिससे हम mirror बना रहे हैं उसकी जो radius होती है वही हमारा जो mirror है उसकी क्या कहलाती है? radius of curvature. Now next point is principal axis. So what is a principal axis? It is the straight line. The straight line joining the pole and the center of curvature is called principal axis. So as shown in these diagrams, our center of curvature is denoted by C, the pole is denoted by P. So a line which is joining the center of curvature and a pole, we can extend this line in a both sides. So that is called a principal axis. Now next one is a focal plane. So what is a focal plane? A plane passing through the principal focus and are right angles to the principal axis of a spherical mirror is called focal plane. So to understand a focal plane, we also need to understand the what is a principal focus. So further afterwards we will define the principal focus also. So you can more understand this focal plane term afterwards. Okay, now next is a focal length. So what is a focal length? Focal length is the distance between the pole and the focus. So let's once I just define a focus also. What is a focus or a principal focus? When the light rays comes parallel to the principal axis and after reflection they will cut the principal axis at a point. ओके क्या बोला कि प्रिंसिपल एक्सिस के पैरेलल कोई लाइन आती है, कोई रे आती है, लाइट रे, और पैरेलल आने के बाद जो वो मिरर से रिफ्लेक्ट होती है और रिफ्लेक्ट होकर प्रिंसिपल एक्सिस को यहाँ पर कट करती है, वो जो पॉइंट होता है उसको क्या कहते हैं? प्रिंसिपल फोकस ऑफ अ मिरर. ओके, सो प्रिंसिपल फोकस पर जो प्लेन बनाएंगे हम, परपेंडिकुलर प्लेन, प्रिंसिपल फोकस पर प्रिंसिपल एक्सिस के जो परपेंडिकुलर प्लेन बनाया जाता है उसको क्या बोलते हैं? फोकल प्लेन कहते हैं. और प्रिंसिपल फोकस से लेके पोल तक की जो दूरी होती है उसको क्या बोला जाता है? फोकल लेंथ. ओके, द डिस्टेंस बिटवीन द principal focus and a pole is called focal length. Now let's define the next term. Next term is the aperture. So what is a aperture? Aperture is the surface which is exposed for the इंसिडेंट लाइट. जो इंसिडेंट लाइट आ रही है उसके लिए किसी भी मिरर की जितनी सरफेस ओपन होती है, जितनी सरफेस अवेलेबल होती है जहाँ पर कि वो लाइट आके इंसिडेंट हो सकती है और रिफ्लेक्ट हो सकती है, वो जो सरफेस होती है वो उसका क्या कहलाता है? एपरेचर कहलाता है. ओके, और ऑल्सो वी कैन डिफाइन अ एपरेचर एज द साइज ऑफ द मिरर. Okay, so now you understand all the terms. The terms again we summarize. A pole क्या होता है? जो मिरर फॉर्म कर रहे हैं, उस मिरर फॉर्म किया जा रहा है उस मिरर का जो सेंटर पॉइंट होता है उसको क्या बोलते हैं? पोल कहते हैं. सेंटर ऑफ कर्वेचर क्या होता है? सेंटर ऑफ कर्वेचर जिस होलो ग्लास स्फीयर से आपने मिरर फॉर्म किया है उसका जो सेंटर होता है वही मिरर का सेंटर ऑफ कर्वेचर कहलाता है. रेडियस ऑफ कर्वेचर क्या होती है? जिस होलो ग्लास स्फीयर से आपने मिरर को फॉर्म किया है उसकी जो रेडियस है वही जो मिरर है हमारे उस मिरर की रेडियस ऑफ कर्वेचर कहलाती है. प्रिंसिपल एक्सिस क्या कहलाती है? सेंटर ऑफ कर्वेचर और पोल, इनको जो मिलाने वाली लाइन है उसको अगर दोनों साइड अपन बढ़ा दें तो वो कहलाती है प्रिंसिपल एक्सिस. प्रिंसिपल फोकस क्या कहलाता है? प्रिंसिपल फोकस होता है कि जो लाइट रे है वो प्रिंसिपल एक्सिस के पैरेलल आती हैं और रिफ्लेक्शन के बाद प्रिंसिपल एक्सिस को जहाँ पर कट करती हैं वो पॉइंट जो होता है उसको प्रिंसिपल फोकस बोला जाता है. प्रिंसिपल फोकस पर जो प्लेन होता है जो कि प्रिंसिपल एक्सिस के परपेंडिकुलर है उसको बोला जाता है फोकल प्लेन. ओके, और जो फोकल लेंथ होती है, फोकल लेंथ इज अ डिस्टेंस बिटवीन अ प्रिंसिपल फोकस एंड अ पोल. Now in this slide we will learn what is principal focus and how we can classify the principal focus for the concave mirror and the convex mirror. So you see two diagrams are there. So a diagram which is on the left side, so the mirror we have there is a concave mirror. Why it is a concave mirror? Because the reflecting surface is inward. So because reflecting surface is inward, so that this mirror is a concave mirror, and there is a principal axis. So what is happening? The light rays, you can see the light rays, these light rays are coming parallel to the principal axis. So when a light rays are coming when the light rays are coming parallel to the principal axis and they are incidenting on a concave mirror on a reflecting surface, so after reflection they will meet at a point, or they will cut each other at a point on a principal axis. So at a point where they all are converging, so that point is we say principal focus. So this is in a first diagram, this is a principal focus of a concave mirror. Now you can see that all these lines are the form lines. So form lines indicating that these lines are actually meeting at that point. These lines are actually meeting at that point. So it means that this principal focus is a real one. This principal focus is a real one. So now you understand how we can find out the principal focus of a concave mirror लाइट रेज जो है, these light rays are coming parallel to the principal axis and after reflection they are actually meeting at a point on a principal axis. So that this point is called principal focus and this principal focus is a real, and because it is real so that we draw a firm lines there. Okay, now we move to a convex mirror. Now we can see here in a convex mirror again we always consider in a 10th class that the light rays are coming from the left side to a right side. So in this diagram also the ray of lights are coming from the left side to a right side. Now they are parallel to the principal axis. Now they are incident on the reflecting surface of a convex mirror. So after reflection they are diverging, they are going far from each other. Like in a first diagram the rays after reflection converging, they are converging and actually meeting at a point on a principal axis. Now in a second diagram for a convex mirror, after reflection the rays are just diverging. Now if we move them in a backward direction, extend them in a backward direction, they appears to meet at a point on a principal axis. Now because they are not actually meeting at a point on a principal axis, they are appears to meet at a point on a principal axis, so that we denoted by them by a dotted line. Now because they appears to meet on a point on a principal axis and that point is called principal focus for a convex mirror. Now this principal focus is a virtual one. Why? Because the rays are not actually meeting at that point, they appears to meet at that point. Okay, so what we learned that for a concave mirror the principal focus is a real one and the rays are converging after the reflection, and in case of a convex mirror after the reflection the rays diverging, but if you extend them in a backward direction they appears to meet at a point on a principal axis. So where a point there appears to meet, it is a principal focus for a convex mirror. Now you can read these 2 points which is just given above. Focus of concave mirror: a parallel beam of light after reflection from a concave mirror converges at a point in front of the mirror. The point F is the focus of a concave mirror and it is a real. Now for a convex mirror, a parallel beam of light after reflection from a convex surface diverges and the rays do not meet. However, on producing backward, the ray appear to meet at a point behind the mirror. This point is focus on the convex mirror and it is virtual. Okay, thank you. Now we move to the next slide.